All right, part E, we're almost at the end here. This is the last part. Now we're moving along in this titration, and let's say that we've added 60 milliliters of sodium hydroxide. So we know from part D that 50 milliliters was the equivalence point. But what would the pH be if we went ahead and added an extra 10 milliliters? So that's 0.06 liters of solution, and we know that we added 0.4 molar sodium hydroxide. So that means we must have added 0.0240 moles sodium hydroxide total. We know that we had 0.02 moles of the hypothetical acid, the benzoic acid. So that means that 0.02 moles of that reacted with the base. So in order to figure out how much sodium hydroxide is left, I subtract the 0.02 moles that were reacted. And so that means I have 0.004 moles of sodium hydroxide in excess after I do the titration. Now that means that there's OH ion in the solution, and certainly there's definitely some A- in the solution as well. When the A- is in there with the strong base, only the strong base contributes to the pH. So it's the only thing affecting the pH. You can do an ice table where the initial concentration of OH is not 0, go through the exact same process of solving for the final concentration of OH, and you will see that it does not change at all. So in order to figure out the pH, we just need to figure out the concentration of OH. And so we know that we had 0.0400 moles of the OH minus, and it's in 0.160 liters, right? Because we started with 100 and we added 60 milliliters. So now we have 160 milliliters. So the concentration is 0.025 molar in hydroxide. So the POH equals negative log of that value, and I get 1.6. And so the pH equals 12.4. And that's it. That's the last part of acid-base chemistry. If you can go through and you can do a weak base, strong acid, or weak acid, strong base titration in each of these different places in the titration, just like we did in this problem, then you have mastered this chapter.